Lily is a 36-year-old lady. Over the past 18 months, Lily has experienced numerous ongoing and severe headaches, irregularity of her menstrual cycle and flow, a noticeable decline in her attention span and concentration, and a concerning decrease in her peripheral vision, having nearly collided many of times with other vehicles on the side of the road. Today, she is visiting her GP about some troubling health concerns. Upon her visit, Lily explains her concerns and symptoms to her GP, who then conducts a physical examination. Upon this examination, Lily's GP confirms a decrease in Lily's peripheral vision. The GP decides to take a sample of Lily's blood to conduct various tests. Lily is then referred to a radiologist to undergo an MRI scan of her head. MRI stands for magnetic resonance imaging, a method used to generate images of the body's internal organs and systems. An MRI is useful in detecting abnormal physical changes within the body that cannot be detected by a physical examination. Lily's MRI scan shows an abnormal mass beneath her brain. This mass is diagnosed as a benign neoplasm of Lily's pituitary gland. Being a solid mass, this neoplasm is considered a tumour. This type of tumour is called a pituitary adenoma. Let's conduct some research to further understand Lily's diagnosis. Like all living organisms, our bodies are made up of cells. Cells are living units that mature, reproduce, and eventually die. Cellular division, known as mitosis, is essential for the survival of an organism and is a natural part of a cell's life, or what we call the cell cycle. Within this cycle are checkpoints at which the cell is examined for normality before it undergoes cellular division. This ensures the proliferation and replacement of these cells with normal, healthy new cells. Disruption of this normal cell-checking process can, however, lead to the uncontrolled proliferation of abnormal or unhealthy cells. This is neoplasia. A neoplasm is the result of neoplasia and is often referred to as a tumour. Neoplasms, or tumours, are abnormal masses of tissue which serve no physiological purpose and can be either benign or malignant in nature. Neoplasms arise as a result of cellular DNA mutation. Neoplasms arise when two specific genes within the cell's DNA, the proto-oncogene and the tumour suppressor gene, are altered in a way that disables their normal function. These genes and their products detect abnormalities within the cell's DNA. If mutations or abnormalities are detected within a cell's DNA, an apoptotic pathway is activated by these genes. This is referred to as a programmed cell death. Mutation and alteration of the proto-oncogene and tumour suppressor gene can, however, change this self-destructive process. When these genes are altered by carcinogenic or hereditary means, they cannot detect mutated cell DNA and therefore do not activate apoptosis. These cells are then allowed to proliferate and accumulate within the body. As previously mentioned, neoplasms can be either benign or malignant in nature. Benign tumours are not cancerous, whilst malignant tumours are. The characteristics by which neoplasms are categorized as either benign or malignant include the degree of differentiation of their cells, the ability of the tumours to spread or metastasize, the rate of the cellular mitosis or growth, the tumour's ability to produce hormones, and the level of destruction the tumours can cause to surrounding tissues and structures. Benign neoplasms are well differentiated, meaning the cells of the tumour still resemble the normal cells of their surrounding tissue. Malignant neoplasms, however, vary in appearance and generally look quite different to the normal cells of their surrounding tissues. This means they are less differentiated. The mitotic activity of benign tumour cells is slower than normal, whilst malignant cells have increased amounts of mitotic activity, enabling them to grow fast. Benign tumours cannot produce hormones, whilst malignant tumours can. Most importantly, benign tumours cannot invade other tissues and systems. Their growth remains localized and generally affects the surrounding structures and organ systems by compressing, blocking, or disturbing their normal function. Malignant tumours can, however, invade surrounding tissues and organ systems. Once malignant cells have entered the circulatory or lymphatic system, they can migrate to distal organs and cavities in which secondary malignancies can arise. This is called metastasis. Benign tumours are often named according to the tissue from which they arise, with the suffix "oma". Benign tumours can occur anywhere within the body from any type of existing cell. In Lily's case, her tumour is called an adenoma. An adenoma is a tumour that arises from glandular cells. Lily's adenoma has resulted from the proliferation of neoplastic cells of her pituitary gland. At Lily's next doctor's appointment, her GP explains the effect the tumour is having on her body and how this relates to her symptoms. The pituitary gland is a small endocrine structure suspended beneath the brain. It is connected to the brain's hypothalamus and sits a few centimetres behind the eye sockets, just below the optic nerve. Its role within the body is to produce, release and regulate 9 specific hormones that control basic functions of growth, metabolism and reproduction. As Lily's tumour is not functional, meaning it is not producing hormones, it is simply a growing mass within the skull. The skull contains a fixed intracranial pressure, accounting for and including the normal structures found within, such as the brain and its components, the pituitary gland, the meningeal tissues, and cerebrospinal fluid. The growth of a tumour, benign or malignant, increases this intracranial pressure and compresses the structures within the skull. This is referred to as a mass effect. The compression of the pituitary gland can cause a significant decrease in its hormone production and release. A decrease in the production and release of hormones that are involved in the reproductive system ultimately affects the reproductive organs of the body. This explains the irregularity and disturbance of Lily's menstrual cycle. The mass effect is also responsible for Lily's visual impairment, as the pituitary gland is located beneath the optic nerves behind the eyes. Compression of the optic nerves at their point of crossover, the optic chiasm, can cause both impairment and total loss of vision. Common symptoms of a compressed optic chiasm include blurred, double, and tunnel vision. As previously mentioned, the mass effect of the pituitary adenoma can also lead to the compression of the local brain sectors and structures, such as the hypothalamus, the temporal lobe, the ventricles, and the meningeal tissue layers. So what does this mean for Lily in terms of treatment? The treatment of a pituitary adenoma is dependent on the size and function status of the neoplasm. Medications are often prescribed to shrink the size of the tumour and suppress further growth. Certain medications can also counteract hormone production or depletion and therefore alleviate symptoms by restoring hormonal balance. If required, the mass can also be surgically removed. This can occur endonasally through the nasal sinuses or via a craniotomy, the surgical opening of the skull. In cases where medications are ineffective or where surgery is not appropriate, radiology may be commenced. Lily's GP commences her on appropriate medication and reassures her that her situation is under control. With the appropriate medical treatment for her benign pituitary adenoma, Lily can resume living her life as normal without any further concerns.